In its simplest terms, biodiversity is the number of different species that call a particular area home. Biodiversity provides us with a number of services that are sometimes called ecological services. They provide us with food, they provide us with building materials, they filter our water and keep water clean, and in many cases, species perform functions that we haven't yet identified, and it's important to preserve these species, not only for the roles they play in supporting human lives, but also because they've evolved here for millions of years. We have the responsibility to make sure they stay here and they don't go extinct on our watch. Here at the River Institute, although we're a river research institute, we not only study rivers and the animals that live in the river, we also study the wetlands, the woodlands that surround the river ecosystem and connect the river ecosystem to the terrestrial landscape. So we study everything from microbiology to water chemistry to rare and threatened species that make the St. Lawrence River home. In this episode, you'll accompany me as we study one of those rare species that is the focus of much of my research these days, the cutlet minnow. So there are a number of different reasons why I'm interested in the cutlet minnow. First of all, it's a threatened species, it's rare, and it has a very small range in Canada. It's only found in the St. Lawrence and Ottawa River drainage basins. Many of these sites are records of only one or two or a small number of fish. So it's rare. It also has some really strange mating behaviors that we don't understand very well. It builds these large rock nests that you can see here. Males spend a lot of time rearranging the rocks in the nests, defending the nests, and we don't really know what all these behaviors are about. We're trying to document using GoPro cameras the mating activities and the territorial behaviors of these fish, because obviously if we want to recover a species population, we need to understand the breeding habitat it uses, we need to be able to measure its population size, and we need to understand what features of the habitat are important for it to reproduce successfully. The first site we're going to visit today is a small creek near downtown Cornwall, which I call Rotary Creek. So we're out here looking for nests and trying to identify nests where we can then go and record reproductive behavior of these fish. Now the kinds of places they like are places where there's lots of current, more than this right now. Right behind a rock like that you'll often see a nest, and you'll see a large male guarding that nest. I'm going to flag this one to check another time. It's a little too dispersed. In past years there were some nests in this general area, so this is a spot we want to look carefully. If this is a nest, it's just the beginnings of one, so that's one to keep an eye on as well. So that's good enough that I'm going to number that one. And then the first time that you guys confirm that it really is a nest, then we'll update that and we'll say nesting activity confirmed on whatever, August 1st or whenever you actually see a fish. The good news about this rare and threatened species is the more we look for this fish, the more we're finding it. We've discovered a number of new locations for this species that have previously not been documented. So the good news is it might not be as rare as we first thought, but it does have very particular habitat requirements. So we'll do the snorkel transect first so that we don't disturb all the potential nests. Mostly we're going to stick close to the reef because that's where the cutlets have been historically caught. So what we're doing here is we're looking for large piles of small gravel in the shelter of larger rocks, similar to what we saw in the last video. And you can see here lots of large rocks and lots of crevices in between the rocks which provide appropriate shelter. But the rest of the habitat, the rest of the substratum, is mostly weeds or sand, not a lot of that fine gravel. I counted 133 gobies and 1 smallmouth bass, and put YOY, Young of the Year, in brackets by smallmouth bass. No cutlets and no nests. I guess I'll try going up against the current. It'll help the pocket extend better. So Josh, just feed this out to me as I go.
You can just follow that pocket.
So what you can see here with these seine nets is we basically start from shore and we make a big circle. We corral the fish in a particular area, and then we pull the net in. We make the corral smaller and smaller until we've got fish in a small pocket of the net, and then we hoist the net out of the water, and hopefully we catch some fish.
24 gobies.
Doesn't look like on this particular haul we caught too many fish, and we certainly didn't catch a cutlet minnow. And as you can see here, one of the traits that's important in scientists and in particular biologists is patience. We spend a lot of time looking for fish with no success. By definition, we're studying a fish that is threatened. That means we're not going to catch huge numbers of it.
Crayfish. 1 blunt nose and a crayfish. Are we going to do another one, or?
Okay, there, it's back down in the pocket. Just make sure they're not young cutlets.
No.
No?
What is that, just a small shiner, I guess?
So in addition to measuring habitat and catching fish, we also take a few standard water quality measurements to see if there are any particular features of water quality that are associated with successful cutlet minnow breeding. We think fairly clear, clean water is important to them. And so here we're measuring turbidity, which is a measure for the cloudiness of the water. So get ready to drop the cork in 5 seconds. So we have fancy high-tech instruments for measuring water velocity, but I always like to do an old-fashioned technique of measuring off a fixed distance and then watch timing, how long it takes a cork to float downstream. One of the problems with the more high-tech instruments like the one that Josh is using here is that if they get banged around in the fast-moving water and get damaged, those meters will still give you some sort of a reading even though the machine is no longer properly calibrated. So we're leaving this study site now. We didn't have any success here, possibly for the reasons I mentioned, the lack of appropriate substratum, especially the small gravel-sized rocks. And we're heading off to another site. We'll see if we have some better luck. We're going to have a massive haul. Can we just make like a funnel and dump them?
This is insane. You just caught every fish or order creek. Are we counting them?
Yeah, count them, but keep a count in your head, and you keep our count in case I'm talking back and forth.
Okay, well, let's me and you will team up, and
so
they'll team up, and that'll be easier.
51.
5 more. There's a killifish in here.
Okay. So you can release him too, just we'll remember him separately. 62. How many? 52?
Yeah.
Okay, so you can start again at 0, and they were common shiner?
Yeah, that's all I'm doing right now.
Okay. Although we caught hundreds of fish in this haul, we once again didn't catch a cutlet minnow. So we're going to go now to yet another site. We're going to use a different technique for this site. We're going to use a technique called boat electrofishing. This is a specially rigged out boat that delivers an electric current into the water. So you can see that I'm wearing rubber boots and rubber gloves, and I have a net that's connected to a fiberglass pole. The same kind of grade that hydro linemen would use. And so what the electric current does is it stuns the fish. You can see these fish are floating belly up. They haven't been killed. They've been temporarily stunned, and they will recover. Also allows us to get into places where it's a little bit hard to get into with a seine net, and hopefully we'll have some better luck at this site. All right, that's good. Yeah, so there's one that could have been a cutlet minnow. It looks like we didn't catch any cutlet minnow, but I'm going to pass the bucket off to my shore crew, and they're going to have a closer look. They're going to document all the species we caught. While they're doing that, we're going to move off to another site, not too far away, and hopefully we'll have some better luck there. So my crew's off now at a nearby island where we've had some luck in the past, and they're going to do a short transect. So there, it looks like that one of those fish there looks like we might have caught a cutlet minnow. We'll have to have a closer look, but that looks like it could be a cutlet minnow.
Hard.
It is.
Especially when they fall, they dive down sometimes, and then you...
Yeah.
All of them?
55.
That is a big cutlet.
Can I get in here, Joe?
What's that?
This guy's a monster.
That big one's a cutlet?
I think so.
Oh. So we're bringing our precious cargo back to the shore crew. We're going to measure them and weigh them and color tag them. Is that water been changed in that bucket?
Not yet.
Maybe empty and refill it.
Huh?
And there's one of the cutlet minnows there. He's starting to come to. You can see his gills are moving. He's breathing fine. So each fish that we tag, we carefully record the color and the location of the color tag so that we can identify each individual fish upon recapture. Yeah. That's not a one-eyed fish, is it?
Yeah, I think it's a rock bass.
With one eye. Proof. Oh, that is pretty cool. One of the bizarre things about these cutlet minnow is they use their lower lip, which is designed for picking up those pebbles, in a secondary way. They use it also as a defensive weapon. So when a would-be predator tries to attack a cutlet minnow, it attacks that would-be predator in the eye, and it rips its eye out of its eye socket. And although it sounds a little bit gruesome, it's a really interesting way of using an adaptation you already have for building nests as a defensive weapon. Is the anesthetic already mixed up? We want to keep them anesthetized to minimize stress and also make it easier to tag them safely. Do we have a weighing dish for the balance? So this is anesthetic?
Yes.
And that's recovery?
That's a big one.
Yeah, you haven't done any that big, have you, at that site?
No, we all probably like 60, 70 mils.
5.9 grams, 132 millimeters. These tags, we give them fluoresce under UV light. Before we tag a fish, we want to make sure it doesn't have a pre-existing tag. 8.1 grams for the next one, 92. 12.1, 105 millimeters. All right, and it's untagged.
Is that good?
So here you can see the two previous fish we tagged have already recovered. They're swimming upright, and by the time we get back to the release site, all four of those fish, as you can see here, will be swimming upright. So this one has perfectly recovered, anxious to go home to his nest. Well, that brings us to an end of this episode, and also to the conclusion of our series on biodiversity. I hope I've inspired you to get out there, open your eyes and ears, notice and explore the biodiversity around you. For those interested in more, check out our website. We have programs for school groups. We have one-on-one mentorships, volunteer and summer student opportunities for those who are maybe thinking of a career in conservation biology. I'd also like to thank our supporters, Raisin Region Conservation Authority and the Ontario Power Generation people who have always supported our biodiversity research at the St. Lawrence River Institute.